Hey guys, so one more video. We have to look at the situation where you're finding the area between two curves, but the curves switch position at their points of intersection. So I'm going to try to take this one step at a time. Hopefully it'll work since I don't have a whiteboard and I can't use the one on my iPad or my computer. So if you can follow along with me here, it'll make sense and you can go slower whenever you have a chance, okay? So here are the two equations that we're going to work with, okay? So 3x cubed minus x squared minus 10x and negative x squared plus 2x. Two different equations, okay? The first thing you want to do is find the points of intersection. So you're simply going to set the curves equal to each other, combine like terms, factor, and get your points of intersection, in this case, to be 0, let's go this way, 0 and 2. Okay, so 0 and plus or minus 2 would be your 2 points of intersection over here. Okay, now I graphed the graphs and you can see that the graphs themselves are switching position. All right, so the bottom graph here is f of x, okay? But on the other side, it's the top graph. So it switches position and the points of intersection are at -2, -8, 0, 2, and 2, 0. So there's two areas you need to consider. You need to consider this area that goes from 0 to 2, and you need to consider this area that goes from -2 to 0. Okay? So to do that, we're going to set up I'm sorry, I'm just trying to get used to this camera, but we're going to set up two integrals. Okay? So we have this integral, f of x minus g of x, and then we have this integral, g of x minus f of x. Okay? So in the first integral, the top curve is your 3x cubed minus x squared minus 10x, and your bottom curve is your minus x squared plus 2x. For this interval, your top curve is negative x squared plus 2x. Your bottom curve is 3x cubed minus x squared minus 10x. Okay? So two different regions. When we simplify them and set them up as integrals, you're simply integrating going from 2 to 0, x cubed minus 12x dx. Going from 0 to 2, negative 3x cubed plus 12x dx. Now, I got those just by simplifying the step above. Okay, you integrate, you have 3x to the 4th over 4 minus 12x squared over 2, which is 6x squared. You're going from -2 to 0. And on this integral, you have negative 3x to the 4th over 4 plus 6x squared, and you're going from 0 to 2. Okay? So all I did first was find the points of intersection, then look at the two areas. You always say the top curve minus the bottom curve. So even since they switch position, you have to take them as two separate integrals. And then I plugged in 0 here. Okay, so 0, 0. Then I plugged in -2, and I got 12 minus 24. Over here, I did the same thing, but I plug in 2 first and get -12. I plug in 0 and get 0. So I end up with, over here, getting a minus -12, which is 12, and over here 12. So if I add my two integrals together, I get an area of 24 square units. Now, if I knew that these areas were symmetric, or I knew in some way I could just double one side to get the other, they're all things that, if you remember your Algebra 2 and your pre-cal, you may remember. If you're uncertain, then it doesn't hurt to just do the two separate integrals rather than testing the function for symmetry. I mean, obviously, by the way I graph, you can tell that you can't tell by my graph that they were symmetric, okay? Hopefully this helps. This example is also in the textbook, but I thought if I walked you through it, it may be a little bit better. All right? See you soon.